Well, if I'm being honest, I never forgot about string theory. It's remarkable. It's the closest we've come to a theory of everything, something even Einstein couldn't figure out.
Well, if he couldn't figure it out, maybe it's just wrong.
But it's so elegant. I mean, look, string theory posits that the fundamental particles we see in 3 dimensions are actually strings embedded in multidimensional spacetime.
Interesting. So that would mean that. Can't do this by myself, buddy. So it's sort of like a guitar string, but instead of making an actual sound, each vibration is a different particle.
Precisely. And when you express it in 11 dimensions, Einstein's relativity equations pop out. Does that sound like a coincidence?
It does not.
Yep. That's what I think.
So did we do it? Did we just solve string theory?
Oh, I appreciate your enthusiasm, but this is not the sort of thing we can figure out in a night. People have been stuck on this for decades.
What, decades? Really? It's a string. How hard can it be? It's straight, it's in a loop, it gets knotted up with other strings.
Well, actually, there are no knots in anything greater than 4 dimensions. Well, unless we get around that by considering them as sheets. You know, topologically speaking, that has a lot of interesting possibilities.
See? How long did that take me? Like a minute?
I thought you were getting us dinner.
Sorry, I had to stop at Sheldon's and help him solve string theory.
What?
Yeah, it turns out the answer's knots.
That's cute, but you can't have knots in more than 4 dimensions.
You can if you consider them sheets. Good night.
In the Solo Oscillation episode of Season 11 of The Big Bang Theory, Sheldon explains string theory and dark matter to Penny in his apartment. The episode begins with Sheldon struggling to come up with a new idea for his research. He is feeling discouraged, but Penny encourages him to keep trying. She expresses her interest in learning about string theory, and Sheldon agrees to explain it to her. Sheldon starts by showing Penny a piece of string and explaining that according to string theory, the universe is made up of tiny, one-dimensional strings. He then uses the analogy of a guitar string to explain how the vibrations of these strings give rise to different particles and forces in the universe. Penny asks Sheldon about dark matter, and he explains that it is a mysterious form of matter that does not interact with light or any other form of electromagnetic radiation, and is therefore invisible to telescopes. Sheldon suggests that dark matter could be made up of particles that exist in extra dimensions beyond the 4 dimensions of spacetime that we observe. Okay, let me explain a little bit about string theory. String theory is a theoretical framework in physics that attempts to unify all 4 fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The theory suggests that at the most fundamental level, all matter and energy in the universe are made up of tiny, one-dimensional objects called strings, which vibrate at different frequencies to give rise to the various particles and forces in the universe. One of the interesting features of string theory is that it predicts the existence of additional dimensions beyond the 3 spatial dimensions and 1 time dimension that we experience in our everyday lives. These extra dimensions are thought to be curled up or compactified at a very small scale, which makes them invisible to us. One of the fundamental postulates of string theory is the prediction of a massless spin 2 particle known as the graviton, which is the force carrier for the gravitational force. In the classical limit, string theory should reduce to general relativity, which has been confirmed by many tests and experiments over the past century. This means that the equations of general relativity should emerge naturally from the equations of string theory in a certain limit. In string theory, the graviton emerges naturally as one of the vibrational modes of the string. As the string vibrates in different ways, it can give rise to different particles, including the graviton. The properties of the graviton are then determined by the geometry of the extra dimensions in which the string is compactified. String theory does not offer a direct explanation for dark matter, but it provides a theoretical framework that allows for the possibility of its existence. Dark matter is a form of matter that does not interact with light or any other form of electromagnetic radiation and is therefore invisible to telescopes. Its existence is inferred from its gravitational effects on visible matter and light. One possible explanation for dark matter in the context of string theory involves the existence of extra dimensions beyond the 4 dimensions of spacetime that we observe. In this scenario, dark matter could be made up of particles that exist in these extra dimensions and do not interact with visible matter and light in the same way as ordinary particles do.